With breathtaking simplicity, its rhythms fuel the complexities of human passion. It will beat 2.5 billion times over a lifetime, pumping 50 million gallons of blood. No other organ is so married to the human spirit, for its very existence is the pulse of life. Explore the mysteries of the human heart, next on Body Atlas. It takes two to tango. And it takes two to fall in love. Two minds in tune, two hearts beating as one. But the inside story of the heart belies its popular image. It harbors no emotions. The heart is simply a pump, driving blood to the furthest extremities of the body through a labyrinth of blood vessels. The heart is unique among our internal organs. It's the only one we can feel working, especially when we dance, exercise, or make love. The sound of a heartbeat is an affirmation of life. It's a sign that every part of our body is being suffused with fresh blood, providing energy, health, and vitality. Blood is the river of life. In its journey around the body, blood delivers essential supplies to every cell. It's also the universal garbage collector, carrying away waste products from our hard-working muscles. Blood loads and unloads its supplies in the smallest vessels, which weave their way between the body's cells. The deliveries include food, water, and other chemicals, but the most urgent cargo is oxygen. Every cell in the body must have a continuous supply of fresh oxygen. To keep on their feet, Miguel and Nubia need a ceaseless flow of blood in generous quantities. From top to toe, the human body contains 1.5 gallons of this life-giving fluid. Blood travels an intricate network of vessels through every muscle, tissue, and organ. Joined end to end, they would stretch 100,000 miles, long enough to circle the world 4 times. The heart provides the push that keeps the blood on the move. In large vessels, blood positively races along at 1 mile per hour. By the time it's reached the smallest capillaries, it has slowed down to 1,000th of this speed. This slow crawl gives blood plenty of time to exchange material with the body's 60 billion cells. The heart can rev up or slow down the entire circulation. A relaxed body doesn't demand a lot of oxygen. The heart beats slowly, and the blood takes a whole minute to go all the way around. But exercise or excitement makes cells hungry for food and oxygen. The heart pumps faster to keep them well supplied. Miguel's blood is now racing around his body in only 10 seconds. The blood flow to his hard-working muscles has gone up 20 times. His heart is pumping 30 pints of blood every minute. Even for somebody as fit as Miguel, it takes time for his heart rate to get back to normal. As he recovers from his exertions, his body still needs extra supplies from the blood, in particular, oxygen carried by special cells. Blood is thicker than water because it contains several types of cell. The red oxygen-bearing cells give blood its characteristic color. Without them, it's a pale shade of yellow. Every pinprick of blood contains 5 million red cells. There are 2,500 billion, about 40 for every other type of cell in the body. The red cell is packed with containers specially engineered to carry oxygen. In this computer model of hemoglobin, 4 tiny yellow regions are crucial. These act as magnets for oxygen. The rest of this huge molecule, an assembly of 10,000 atoms, is only a shelter for these very special sites. The lungs contain a dense filigree of blood vessels wrapped around tiny air-filled sacs. Here, hemoglobin is loaded with oxygen. 1/5 of the blood is always in the lungs doing this vital job. A torrent of blood flows through millions of capillaries that interlace the lung tissue. Oxygen in the air sacs passes easily through the thin dividing walls into the blood to be lapped up by the red blood cells. Blood has a blue tinge when its oxygen stores are low. As it takes this vital gas on board, it flushes a healthy red. The liquid supply of oxygen is now ready to travel to where it's needed. And that's the job of the heart. Nestled between the lungs at an odd angle, the heart is a little larger than a fist and weighs less than a pound. This scan shows a living heart in action, rhythmically pumping blood. Despite popular belief, the heart lies in the middle of the chest, but the strongest pulsations are in the lowest part. That's why we feel our heartbeat on the left side of the body. When resting, the heart beats 70 times a minute, 100,000 beats per day for a lifetime. Every beat pumps 1/15 of a pint of blood, the amount of wine left in this glass. The heart's pumping walls are made of an extraordinary kind of muscle cell. Seen through the microscope, individual heart cells are always twitching, each to its own rhythm. But as soon as 2 heart cells touch, they start to beat as one, choreographed by minute electrical currents. A scan of the heart's electrical systems shows currents sweeping across the muscles. They're coordinated by a bundle of nerve cells known as the pacemaker. The pacemaker coordinates the heartbeat. It also listens for messages from other parts of the body, stepping up or slowing down the heart's blood output on request. Muscles demand more blood when they're busy, but strong emotions also stir the heart. Love and fear can both get the heart pounding. This busy organ may look fearsomely complex, but it has a simple blueprint. Valves divide the heart into 4 hollow chambers. They work in pairs to form 2 separate pumps. One pump forces oxygen-depleted blood to the lungs, while the other sends blood all around the body. The walls of the hollow chambers are made of pure muscle, squeezing in a regular sequence. And the tough but flexible valves make sure the blood travels one way only. The heart's 4 valves all look different, but they do the same job. Each squeeze of the heart muscles pushes blood through one way. When the pressure's off, the valve snaps shut to prevent the blood backing up. These hard-working valves broadcast the heart's exertions. As the 2 main valves snap shut in quick succession, they produce the sound of our double heartbeat. The stage is set for the 1-minute sprint of the blood around the body and back. The starting line is the left side of the heart, the stronger of the pair of pumps. Its top chamber fills with oxygen-rich blood from the lungs. The flexible pillars of this biological cathedral are made of muscle and tough fiber. They help to squeeze out the last drop of blood with every heartbeat. The pulsing walls push the blood out through the mitral valve. Its 2 flaps are supposed to resemble a bishop's hat, a mitre. The cords holding them in place are literally your heartstrings. The blood enters the lower chamber, the left ventricle. Here, it's enclosed by the heart's most powerful muscle. When the ventricle is full of blood, the muscular walls suddenly squeeze hard. The valve to the top chamber on the right snaps shut. The blood, loaded with oxygen and energy, is forced out of the heart through the valve on the left, with enough pressure to reach the furthest parts of the body. Beyond the valve lies the body's largest artery, the aorta. This is the beginning of the blood's incredible journey. Ahead lie the first of many arteries branching off. With each beat, blood follows the sharply curved aorta, first upwards and then down again. The heart draws no nourishment from the blood that fills it. Its muscles need a supply from outside, so the first lucky recipient of fresh blood is the heart itself. Small arteries branch off the aorta and turn back to the heart. Dividing into ever smaller vessels, these coronary arteries penetrate deep into the unresting muscles. These narrow vessels are all interconnected. It's a fail-safe mechanism. If there's a problem with blood supply down one route, there's a good chance it can get around another way. Waste products are swept into the system of blue coronary veins, which drain back into the right side of the heart. At the top of the bend, blood is faced with the choice of three major side passages. The openings to the right and left are the arteries to the arms. This is the route to the head. It contains a busy organ that's always hungry for fresh oxygen. Blood vessels must supply the brain with 1.5 pints of blood every minute. About the contents of this bottle. To ensure that the brain can always keep the body running, it's the only organ to receive a constant supply of blood, even when we're relaxing on a night out. The main flow in the aorta sweeps on to supply the middle and lower parts of the body. This blood avoids the distracting side passages to the head and arms and carries on around the curve at the top of the aorta. Through this gradually narrowing tube, the blood continues its headlong journey, back behind the heart and down between the lungs. It reaches another major junction where a pair of wide arteries leads to the kidneys. Blood taking this diversion must pass through millions of microscopic filters, which clear out toxins and remove excess water. The wastes are flushed away as urine down the yellow ureters, another part of the body's plumbing system. But arteries are more than mere tubes. Their strong walls are built from muscular layers. These muscles play an active role in controlling the blood's pressure and transporting it to the places where blood is most needed. Like a river running in reverse, large arteries branch into smaller and smaller tributaries. The smaller the artery, the more dramatically it can affect the blood flowing through. Specialized cells at junctions can direct the flow of blood. They change shape to open or close a connecting blood vessel. Even the tiniest of arteries can manipulate the blood cells streaming through. It may change their speed or even stop the flow completely. All these checks and balances give the blood circulation an enormous flexibility. The versatile arteries can dictate which cells receive favorable treatment. All arteries lead eventually to capillaries. A capillary is only 1/40th of an inch long, its entire length less than the width of a human hair. Capillaries are so narrow that red blood cells sometimes have to bend to squeeze through. This is where blood offloads its vital supplies of oxygen and food and picks up the cell's waste. Stripped of its oxygen and laden with carbon dioxide, the blood must now begin its long journey back to the heart and lungs. Capillaries drain into small veins, which join up to form larger vessels. A vein often lies next to a narrow artery running the other way. The two vessels carry the same amount of blood every second. But the dark vein must be wider. In the arteries, the blood travels fast, pushed along by the strong heartbeat. But it loses pressure in the narrow capillaries and moves more slowly in the veins. So, these vessels must be wider to keep up the same flow. The walls of the veins have no built-in muscles, but they can tap into the energy of their surroundings. Active leg muscles squeeze the blood along. Small valves in the veins prevent the blood from flowing back down again. These valves are more vital to humans than to most four-legged animals. When our ancestors took to standing up, the distance from foot to heart increased by 50%. The returning blood has to travel 4.5 feet against gravity. As the major veins reach the middle of the body, they're no longer surrounded by busy muscles. But help now comes from the muscles we use to breathe. Running up below the lungs, the body's main vein is squeezed every time we breathe in. The expanding chest also lowers the pressure around the top of this vein, sucking blood up towards the heart. At any moment, 60% of our blood is in our veins, slowly making its way back to the heart. That's 3 times the amount of outgoing blood in the heart, arteries, and capillaries. 40 seconds after leaving the heart, the blood is back. It's now the turn of the other pump. The top chamber collects bluish blood from the 2 great veins running in from the body and from the head, and blood from the heart's own network of small veins. In one beat, the blood rushes through a valve into the lower chamber. This valve has 3 flaps, but to prevent it from turning inside out, it too relies on the tug of the heartstrings. The lower chamber, the right ventricle, is the weaker of the heart's 2 pumps. Its muscles need to propel blood on a far shorter and easier journey, only as far as the lungs. The blood streams out for the last stage of its 1-minute circuit, through the lungs and back to the starting line in the left ventricle. On the way, it disgorges the carbon dioxide and takes on board fresh, life-giving oxygen. With this new supply of oxygen, the muscles are refreshed and ready to go again. The heart far outperforms any pump that humans have designed. It's self-regulating, self-repairing, and self-powered. And it's equally powerful as a symbol. Throughout the ages, people have regarded the heart as the center of the human being. It's the universal emblem of courage, friendship, and love.